Hello, my name is Rafael Orozco, and this is my first argumentative examination that it involves 2 problems and 3 questions. Now, in the first problem, it says that there is a spaceship located in this coordinate, and the temperature in space is obtained by this equation. So the first problem, it says where is the direction to advance in order to decrease the temperature most rapidly? In order to do this, we have to make the gradient of the equation of temperature that it says to make the partial derivative of each variable that we obtain these 3 coordinates that is expressed like this. But we have to get rid of these negative signs because this is a gradient and we have to decrease the temperature. In order to get rid of these negative signs, we a negative sign in both sides, and we have a result like this. But if we factorize it, we have that the negative gradient of t, because we obtain the negative from here, in the coordinate of 1, 1, 1, it's equal to e elevated to -6 times 2, 4, 9. That, as I said, is the factorized form from this expression. Now, in B, it says that if spaceship travels at a speed of 8 e elevated to 8, at what speed temperature decreases? This is obtained by the directional derivative times the speed. So the directional derivative is the gradient of t times the negative gradient of t divided by the norm of gradient of t. Obviously, we continue with times the speed. We express it with the previous equation that we obtained. And if we start to resolve all this equation, we have that negative e elevated to 2 times the square root of each variable that we have, each coordinate, sorry, that we have here, squared. And we have a result that minus 74.259 because it's a speed, so it will have a direction of towards negative. In GeoGebra, we express these 2 equations with the number, with the C, that here is where the spaceship is located, and the A is where it has to go in order to decrease the temperature. So as we saw in this vector, it has towards negative as we obtain in these 2 results. Now, in the second problem, it says we have to calculate the volume of the water from a rainwater collecting tank that has a rectangle form, and the X and Y has these 2 limits. In order to calculate the volume, we make a mixed partial derivative, first in X, then in Y. So we use the equation that they gave us in the problem. So first we make the partial derivative in X, and then we make the partial derivative in Y. In each partial derivative, we obtain these 2 functions that if we choose the minimum of both variable, we will get rid of because f will be equal to 0 and g will be equal to 0. So in order to now evaluate to the maximum, in order to obtain the volume, we can get rid of these 2 variables. So we use the rest of the equation. We now substitute the X and Y for 4, 4. And if we resolve it, we obtain that the volume is 64 meters cubic. And that's all. Thank you.